Right now you're listening to the sound of that's the sound that you're getting right now. And this is just a speaker out of an old clock radio. Capacitor, I got a 0.1 microfarad to block the DC. And you just connect that on the system. And we're at about 255 hertz right now. It's pretty sunny. We're 250 watts. Well, I mean, it's not really sunny. It's very overcast. And this is the whole thing put together. Kind of unique. We got here's the power supply. So you got the LED indicating the power supply is functioning. I added a pot so we can adjust the voltage. I have a switch here, and you can see the red LED. And if we flip this switch, the tone changes a little bit, but what really changes is you get 60.2 volts, and now you're at 61.8. A red LED has about a 1.7 volt. I use them a lot to actually create a voltage difference. They act just like a Zener. And you can have this red. This is the winter condition when your voltages are higher because of the cold weather. And then when you hit summer, you could just hit that. Or it could be a setup where you get more aggressive in putting energy to the water heater. I use these for diversion. My camp heats water from just the excess power that is not used to charge the batteries. So when the PV voltage rises, it diverts energy to the water heater. But as you can see, it's kind of a pretty arrangement here. We got a box, protective cover. Now the trouble is these power supplies are very short, and as you can see, it just doesn't go up and meet the gaps in the opening. So if you're using one of these power supplies, I suggest you do a standoff on the DIN rail, put some longer bolts in, something to space it out like some washers, and then you have a nicer looking thing. So like again, you got the switch here. This is at 6,000 microfarads. And if we switch it down to 470, you can see this slope. You know what they say, if you can see a slope, you're a dope. You can get away with small capacitance, but you'll pay for it in the end. It's less efficient, and capacitors are your main storage device. I mean, why do you want to be cheap on those? People always want to be cheap on capacitors. If you have a small capacitor, it'll eventually fail. It's much more efficient, and when you're operating at lower frequency, everything works better. The other day, my water heater is 6 ohms because I have a 60 volt array. It's just my test array, but this is a 1 ohm resistor, and I put it on. Now 60 volts, 1 ohm, you're going to be getting pulses way over 50 amps, and you want to put that through a little capacitor? Nope, not going to happen. So really, spend some money on some capacitors. You can buy cheap capacitors and have a lot of them, or you can buy a couple of them that are much better. But I like multiple capacitors because you're not putting as much stress on each capacitor. So yeah, you don't need any fancy equipment. You can tell if it's working. In the morning when it's just a few watts, this will be clicking away. So let's go upstairs.